Okay, if you go to Canvas, I'm going to show you two things. One is if you go into the course, underneath the little Bitmoji classroom and underneath my information, there is a link that says Calc Chat link, okay? When you click on that box, it's going to take you to a website that's called Calc Chat. How many of you have used Calc Chat before? Anybody? Okay, I didn't know if it was with your Algebra 1 book or not. Calc Chat is your online answers, basically, for all the odd questions from the work. So if you're working through a homework and if you're stuck, you can come in here and you can find an odd question answer. All the odds are here, okay? Sometimes we will give you homework that is only odds with the intention that you are checking your answers as you go, okay? We are aware we're giving you odds. We know what that means. But we want you to be checking your answers as you go. Do not come here and get all of your answers from here and think you know what you're doing. Those are two different things, okay? But for the homework, so let's say I wanted to check my answers for P3, right? If you see, it's going to bring you right here. It says Chapter P. We're picking Chapter P because that's what we're in. We would pick Section 3. And we would go to, I don't even know what numbers I gave you. Let's say Exercise 31. And I click Go. And it's going to give you the worked out solutions for that, okay? This is super helpful for two reasons. One, you can check as you're going, right? Or if you want to do your homework and then come back and check any odd answers, you can. Two, I'm going to show you where you can find your ebook, which has all the questions in there. So if I give you questions and I give you, let's say I give you 2 through 20 even, right? And you have no idea how to do number 6. If you go to your ebook and you look at number 5, it's probably the same kind of question. And then you can come here, you can see the answer, and you might be able to figure out what you're doing wrong. Does that make sense? Yeah. How many of you looked at an answer to a question and then worked backwards to try to figure out how it's done? Liars. 1, liars. 2, okay, all right. It's a good thing to learn how to do, right? So if I didn't know how to do 32, I could come in, I would go to my ebook and I would see if 31 is the same kind of question, and if it is, I can get the extra help that way, okay? So speaking of, everybody's going to follow me right now and do this with me. You're going to open up your iPad. Everybody's going to do this with me. We're going to open up our iPad. We're going to go to Safari. And you're going to go to mccarthyhigh.instructure.com. So I want to repeat. We're going to Safari, not the app. We're going to Safari to mccarthyhigh.instructure.com, and you're logging into Canvas. Then you're finding my class. And you're going to modules. You want to find the module that says WebAssign and then click on the WebAssign Algebra 2 Honors link. It's going to bring you to a screen that looks like this. You're going to click on Create Account. Click on Student. Type in your school email and click Next. And then it's going to ask you to answer your name, your first name, your last name, your ID number, and set up a password. Then it's going to tell you that it's going to send you an email. You want to check your actual email account. You should get an email from Cengage. You're going to click on it, and it says activate account. Click on that to set up your password, and then you should be able to log in. This is where you're going to eventually get your homework and where you're going to find your ebook, which is a great reference. So we had choices here. We could either flip this and get rid of the negative on the outside. But when you flip it, and I said be cautious when we did these in class, because I said if you flip it to get rid of this negative, it doesn't get rid of this negative and this negative. That still stays. So that flips. So my advice when we went over this was to distribute first and then move what's negative. So if I distribute this 2 to the negative third, for this one, you want to distribute the exponent. So the 2 is going to go, the squared is going to go to 3 to the x squared, the y, and the 3 is going to get distributed. 3 squared, x to the 4th, y to the 2nd. And then negative 1 raised to the 3rd. For some reason, people put negative 3, which is not correct. Negative 1 raised to the 3rd power should give you a negative 1. So it should be negative 1, x to the 3rd raised to the 3rd is x to the 9th, y to the 3rd raised to the 3rd is y to the 9th. Then I get negative 3 squared and negative 1 together. I want to multiply those. positive 3 squared is 9 times negative 1 is negative 9. X to the 4th and x to the 9th is x to the 13th. And y to the 2nd, y to the 9th is y to the 11th. Okay, then we got 6 root 39 over 8 root 39. So some of you just simplify the 6 and the 8 because they're both divisible by 2, but that's not enough. Both 39 and 26 are divisible by 13, so I want to reduce that. It would be square root 3 and square root 2. 3 square root 3 over 4 square root 2, but it can't stay that way because you've got a square root in the bottom. So you rationalize by multiplying both the top and the bottom by the square root of 2, and I get 3 root 2 times root 3 is root 6 over 4. Root 2 times root 2 is 2, which is 3 square root 6 over 8. Square root 77 and square root 55 can be broken down. 7 is 7 and 11, 77. 55 is 5 and 11. 2 11s means one goes to the outside, and then 7 times 5 stays underneath. Negative xy squared to the 3rd and 3xy times x squared y to the 5th. You distribute the cube. So negative 1 times negative 1 times negative 1 is negative 1. X to the 3rd becomes x to the 3rd. Y to the 2nd raised to the 3rd is y to the 6th. Then 3 gets multiplied by the 1 that's on the front of the x, which would be 3. X times x squared is x to the 3rd, and y times y to the 5th is y to the 6th. Now these are like terms because both are the same variables with the same exponents. Negative 1 plus 3 would result in 2, x to the 3rd, y to the 6th. 3 root 24 plus root 54. The 24 is going to get broken down in 2, and you could split it 2 and 12, 2 and 6, 2 and 3. The 2 is repeated, so that can come to the outside with the 3. It's going to get multiplied. So that becomes 6, and then the 2 and the 3 that stays underneath would be square root 6. 54 would get broken down into 2 and 27, 3 and 9, 3 and 3. There's 2 3s that can come to the outside. There's nothing there, so it's just 3 square root. 2 times 3 is 6. Now they both have the same radical 6, which means they can combine together. 6 plus 3 gives me 9 square root 6. All right, this might, there we go. Okay, so this is part 2 of which is going to cover factoring perfect cubes and grouping. So yesterday we did perfect square trinomials, difference to 2 squares, and greatest common factor. Now we're going to continue with that. Okay, so we start with factoring perfect cubes. If there's 2 terms and they are both perfect cubes, whether there's a plus or minus in between them, it doesn't matter, we can factor it using this pattern. So if it's a perfect cube plus another perfect cube, then we would cube root them both. And the first set of parentheses is the cube root of each. The second is the first cube root squared, then the product, and then the second one squared. The pattern for the signs is SOAP. Same, opposite, always positive. So the first sign in between the cube roots would match your original question. The second sign would be the opposite, and the last one is always positive because it's going to be squared. So let's look at this first example. X cubed and 125 are both perfect cubes. The cube root of x cubed is x. Cube root of 125 is 5. So it's x minus 5 because we keep the sign the same. Then x squared Middle term is the product of them, which would be 5x. Last term is the last one squared, which would be 25. And the signs go same, so that's minus. Opposite, so in between the x and the 5x is plus. And last is always positive. Okay, let's look at this one. So the cube root of x to the third is x. Cube root of 27 is 3. It would be x, then 3, and it's a minus because it matches, x squared. Then the product, which would be 3x. And the sign is positive because it's opposite. And then the square of 3, which is 9. Looking at the next one, cube root of y to the third is y, cube root of 8 is 2. This would be y plus 2, y squared minus 2y plus 4. For number 3, the cube root of 64x to the third is 4x. The cube root of negative 1, or cube root of 1 is 1, so it's 4x minus 1, x, 16x squared. And then the 4x, and then the positive 1. So the signs, again, go same, opposite, positive. If you want to work it all out and then add the signs in at the end, that's totally fine. Now the last one on this side, 3 is not a perfect cube, and 192 is not a perfect cube. So this is one of those hints that you've got to factor something out. So I want to look at both those numbers. They're both divisible by 3. And I start with factoring out the greatest common factor. I'm going to divide both by 3. I can't get rid of the 3. It stays on the front because it's still part of it. Divide 192 by 3. And I get 64. Now those are both perfect cubes. So the 3 stays on the front. Cube root of x to the third is x. Cube root of 64 is 4. And you get x plus 4. X squared minus 4x plus 16. All right, we're going to save 5 and 6 for tomorrow. Go to 7. Are these both perfect cubes? Yeah, it's ugly, but x plus 2 is raised to the third power, right? So what would be the cube root of that? X plus 2. Cube root of y to the third is still y. So it would be x plus 2 minus y, because it's the same sign. Then it would be x plus 2 squared, which I'm going to come back and do in a minute, plus the product, x plus 2 times y. I'm also going to work out in a minute. Plus y to the third. So the first one stays as it is. Now let's use our special products for the squared. We square the first one, we square the last one, we double the product. So 2x times 2. Bella.
For y equals cubed, isn't it supposed to be squared?
Yes, thank you. This is squared. Then I FOIL this out. Or not FOIL, distribute. And then I want to see, is there anything in there I can combine? I've got an x squared, but not another one. I've got a 4x, but not another, just x. I've got a 4, nothing else. xy, not another xy, just y, and just y squared. So that is a lot of numbers, but that is as simple as it gets. Questions on that one? Yucky, but manageable, yeah? Okay. All right, the last kind of factoring we're going to talk about today is factoring by grouping. This, to me, is the easiest to spot because it's the only thing that has 4 terms. If you have 4 terms, okay, you group them. We're going to group them in pairs. And then from each pair, you're going to factor out the greatest common factor until what's inside the parentheses matches, which you'll see in a second. Then we factor out the parentheses and group together the remaining terms. So here's 4 terms, right? I'm going to group them in pairs. Take those 2 and those 2. Look at the first set of parentheses. Is there a greatest common factor?
Yes.
What can you take out?
X squared.
X squared. So x squared comes off, and this would be divided by x squared, and this would be divided by x squared. So x to the third over x squared is just x, minus x squared over x squared is 1. Now look at the second parentheses. What's my greatest common factor there?
2.
Positive 2. Take out a 2. That means divide this by 2 and this by 2. X minus 1. Now, what's inside the parentheses is the same, which is our goal. If it's not, we got to tweak it. So I take that out, and I group together what's left. X squared plus 2. Okay, try it with 8. 4 terms. They're not all divisible by the same thing, because then I would try to factor out a greatest common factor, but they're not. What can I take out of 8x to the 5th minus 6x squared?
2x.
Good. So divide and divide. This becomes 4x to the 3rd minus 3. What can I take out of 12x to the 3rd and negative 9? 3. Positive 3, 4x to the 3rd minus 9. Are the parentheses minus 3? Are the parentheses a match?
Yeah.
Yep, so that comes out to the front. And I group together what's left. Okay, 9. I'm going to group them. Notice there's a negative in front of that 5. A negative has to stay with the 5. So up here, it doesn't matter because it's plus. It doesn't matter if I push it on the front of the parentheses or not. But if there's a negative on that 3rd term, you have to keep it with the 3rd term. This is not multiplication. We're still going to take something out. But I have to remember that that's a negative 5. So what can I take out of the first one? And I get x plus 1. Second one, what can you take out? So if I took out a positive 5, my parentheses would be negative x minus 1. Doesn't match completely, right? Which is why I want to take out that negative 5. And I get x plus 1 and x squared minus 5. So if you didn't take out a negative 5, your signs inside the parentheses would be opposite, hopefully indicating that you need to take out that negative 5. Okay, we're going to see these last 2 for tomorrow. So we'll do, 5 and 6 and 10 and 11. That's where we'll start tomorrow, okay? But it's the same. Group them, take out your greatest common factor, okay? And then group the answer. So the what are we on? P2B homework is due tomorrow morning. I think it's a blend, again, of odds and evens, so feel free to check the odds. And then your homework is to go back through and redo any of those problems on that quiz that you need the practice for, okay? You're not turning it back into me, that it's for your own gain. But I would definitely make sure that you understand what it is that you did wrong so you don't do it again. Okay.